Around the world, there are 39 million people who are blind, and 246 million people who are visually impaired. These individuals rely on low-tech solutions to aid navigation, such as walking canes and seeing eye dogs, but these aids are cumbersome and can embarrass the user. Advances in technology have enabled us to replicate the functionality of these low-tech aids in an unobtrusive, portable form factor. We created a belt that uses an infrared camera to detect obstacles in the blind user's path and alerts the user using tiny vibration motors around the waist. Here's how it works. As the user approaches an obstacle, the vibrations get stronger. If there's an obstacle on the user's left, for example, the left side of the belt vibrates. From this view, you can see what the belt sees. The video feed on the right is generated from depth data alone. Closer objects are plotted as light yellow, and farther objects are plotted as black. With over 300,000 points of depth data coming in at 30 frames per second, the belt can very accurately detect obstacles in real time. The depth data is divided into 3 zones that correspond to the 3 sets of vibration motors around the belt. The intensity of each vibration motor is calculated based on the distance of the obstacles in that buzzer's zone. This intensity varies exponentially with the obstacle's distance. In other words, there's a finer precision for close obstacles and a coarser precision for far obstacles. In the current iteration, we are using 2 microprocessors to parse the depth data and create the pulse width modulated signals that are sent to the vibration motors to control intensity. In the future, we plan to make several hardware simplifications, including removing one of the processors. In this demonstration, we are plotting the intensity of each vibration motor as the user approaches an obstacle. The vibrations help the user navigate as if he can see. Future improvements include user control and a smarter feedback system that adapts the intensity of the vibrations to the user's environment. We see this technology being used for many purposes besides just aiding the blind. Anyone in a situation with low visibility, such as firefighters or miners, could be assisted using this belt. For more information and project updates, please visit our blog at kinecthesia.blogspot.com.